Okay. Finite state machine, it is a what? Minimal machine, whereas the Turing machine is the most powerful machine. Okay. So all of you remember that Chomsky hierarchy, where there are 4 types of grammar we have seen: type 0, type 1, type 2, and type 3. Okay. So finite state machine, what we have seen, it is a minimal machine. Okay. And finite automata, which is a what? It is a mathematical model of the finite state machine that we have covered. Then we have seen there are 2 types of the finite automata: DFA, deterministic finite automata, and the NFA, non-deterministic finite automata. Okay. So there we have seen that in case of a non-deterministic finite automata, there can be transitions on the epsilon, or there can be more than one transitions for the same input symbol from one state to the another state. In case of NFA, we have seen. Whereas deterministic finite automata is what? There is a possibility of only one transition for the given input symbol from one state to the another state. Then we have compared the powers of this NFA and DFA, and we have seen these are of the same power. Both NFA and DFA have the same power. Meaning is what? For each NFA, there exists a DFA. Meaning is what? We can convert each NFA to the DFA. Same power means what? Both accept the same language. It is not that NFA is accepting a particular kind of a language which is not accepted by the DFA. It is not the case. Both have the same power. Then we have seen what? This accept the regular language. Okay. Finite automata, it accepts the regular language. And what is the regular language that we have seen? Regular language, we have seen it is the type 3 grammar. The language generated by type 3 grammar, it is the regular grammar. There we have seen that what? On the left hand side, there is only one non-terminal, and on the right hand side, only one non-terminal is allowed, which can be appearing as a leftmost symbol or the rightmost symbol. Okay, so this type of productions can be there in the type 3 we have seen. Okay, so this was about what? Finite state machine. Then we have also seen the limitations of the finite state machine. Okay, so in case of finite state machine, what we have seen, there is an input tape, but there we have seen input tape is bounded on one side, and then whatever our input is to be accepted, that is written here on the tape. And there is a head pointer. Using head pointer, we are going to perform the, that is read operation from the current cell. This will say as let current cell. Okay, so at a time it will read one input symbol and it will move ahead. Okay, so head pointer in this case, it can move only in one direction. In one direction is what? Into this right direction. Okay, so after reading the input symbol, the head moves ahead like this way. It will read the next input symbol. So it cannot move backward, that is in the left direction, or it cannot write here this head. Using head pointer, we cannot write to the this tape on the tape. Meaning is what? If your input is DAB, using this head pointer, you can perform only the read operation. You cannot perform write operation on this tape. Okay, so these were some limitations of this finite automata. Other limitations are what? We have seen that we cannot recognize the palindromes. In this case, in case of finite state machine, any other example do you remember that we have seen? Using finite state machine or finite automata, you cannot design or you cannot solve those problems. Palindrome was one problem. What was the another problem? Should remember this. We have seen all this in detail. Palindromes, then what? Well-formedness of a parenthesis. Well-formedness of parenthesis. Any other? Third, can you perform multiplication of two numbers? Multiplication of two numbers. Okay, so this cannot be solved using the finite automata. Okay, so as the name indicates, there are finite number of states. Using the head, you can perform the read operation, that is read one symbol at a time and move the pointer to the right direction. You cannot move backward, that is in the left direction. You cannot write on this step. Meaning is what? I want to change this A to the some other symbol, which is not possible in the finite state machine. Okay, and these are the some examples or the problems that cannot be solved using the finite state machine. Okay, so that's why it is a what? It is a minimal machine. Finite state machine is a minimal machine. Okay, so whereas then next we have seen what? After this regular language, then we have seen what? The PDA, push down automata. What is a PDA? It is a mathematical model of the push down stack memory machine. Okay, so push down automata, like finite automata, is a mathematical model of the finite state machine. PDA is a mathematical model of push down stack memory machine. Okay. Then what we have seen in the PDA, we have seen what are the elements of the PDA. How the PDA is represented. We have seen the PDA uses the stack external memory as a what? Stack. Using stack, we know that we can perform push and pop operations. Okay, so we have seen PDA is represented using. Now tell me the meanings of each of these symbols. There are 7 tuples used. Okay, in case of finite automata, how many tuples are used? I'm just revising now. Wherever you have a problem, you can ask me. You know all this thing. Finite automata is denoted by the 5 tuples: Q, sigma, delta, Q0, and F. Okay, and here we have seen there are 2 functions. Do you remember? Can you anybody tell me? Machine function and the state function. So what is the machine function? Anyone remember? You've seen all this. What is a machine function? This will express in terms of, let us leave this. This will express in terms of input. I is a set of input symbol. S is a set of states, and let O is the set of output symbol. Okay. So machine function here is a what? Given. This we have seen for the finite state machine. If you remember, we have designed 2 tables: machine function and state function table. Okay, so in case of machine function, what we have seen, the input, given the input symbol and the current state, it determines the output. Okay, and in case of state function, what we have seen, given the input symbol and the current state, it determines the next state. Yes, all of you remember this or not? This for the finite state machine. Remember the meaning of this. What is a Q here? Q is a finite set of states. Same meaning here is there. This is your input alphabet. Delta is a transition function. Q0 is what? Initial state. And F is a set of final states. In case of finite automata, how the transition is determined? Transition is same as that of the STF. But now here the notations are somewhat different. Okay. I here हमने input symbol के लिए use किया है, and S is a set of states. What is the delta function? In case of transition function, in case of finite automata, this we have seen for the finite state machine, and in case of mathematical model, we are representing it as a what? Delta. So how the delta is represented? What is the delta? Can anyone tell? Transition function in case of finite automata. Everything forgotten? सब भूल गए क्या? Transition function, how you determine? I have given you the hint. Delta is same as that of the STF, state transition function. State transition function is what? Transition from one state to the another state. So how the delta is determined? Anyone? Number 6, Atharva. Yes, others you can give the reply in the chat. No one knows. Sanket.
Yes, ma'am.
So how the delta is determined here?
It is a finite set of states into finite input alphabet.
No. Given the what? This is what? Your finite set of states. This is your input alphabet.
Input
And it determines the next state. It is so simple now. This is in case of what? DFA. In case of NFA, what we have seen? Q, that is input, that is state, and the input symbol here. In case of, this is in case of what? DFA. In case of NFA, it is what? 2 to the power Q. Remember or not? Power set of Q we computed, and then we found the transitions. Okay. So that was related to the about finite automata, finite state machine revision. Okay. So now push down stack memory machine. What we have seen? This PDA, actually NPDA, it accepts the language generated by the context-free grammar. That is the context-free language. Okay. So we have seen context-free grammar. It is a what? Type 2 grammar. And type 2 is a what? It is the superset of the type 3 we have seen. Okay. So this NPDA, it can accept a regular language as well as the context-free language. Okay. And these are the what? 7 tuples used to indicate the PDA. Okay. So in case of PDA, what is a Q? The same meaning. Q is a what? Finite set of states. This is a what? Summation is the input alphabet. And what is this notation? Yaad hai ya nahi? Third wala notation. What is this? Yeah, it is a stack alphabet, because stack alphabet we have seen it can be different than the input alphabet. Okay, so stack alphabet can have more symbols than the input alphabet, or they can be same or may not be same. Okay, then here delta is a what? Transition function. Now here we have seen transition function. Like in this case, transition function ke liye we need only what? Current state and the current input symbol. Now in this case of PDA, what is added now? Stack is added. Okay. So to find the transition, here we are going to use 3 symbols that we have seen. Okay. That is Q. And this is what? Stack alphabet. So what this indicate? Current state, current input symbol. And this is what? Stack alphabet. It determines what the next state. And this is known as a what? And the stack contents. So this is the stack contents that we have seen. Why I'm taking the revision? Because you should understand which is more powerful, and then why we are going for the Turing machine. What are the limitations of this finite automata or PDA? Okay, so that's why we are considering all this. Okay, so transition function here is like this way. And then Q's, so to find the transition, we need 3 symbols that we have seen. Okay. Then Q0 is a what? It is the initial state. Z0 is a what? Stack top symbol. And F is a what? Set of final states. So this is in case of a PDA. There are 2 types of PDA. Again, we have seen the 2 types of PDA are what? NPDA, non-deterministic, and deterministic. Okay, so in short, I'm saying result is what? DPDA, deterministic push down automata. In case of DPDA, so what we have seen here, if I'm finding the transition, let Q0 is my current state, let A is my input symbol, and let Z0 is my stack top symbol. Okay, so what it determines? It determines the next state. Let my next state is P, and let the stack content something, let, or for to indicate this, we'll use some other notation, let instead of Z0. So what it is indicating that A is pushed onto the top of the stack. Each time the action may be different. The symbol may be pushed onto the top of the stack, or some symbol may be popped from the stack, or nothing is done on the stack. Okay. So instead of AZ0, let I'm denoting it as a let this way, let the gamma. So what this indicate? So this can be empty if Z0 is popped from the stack. Okay, it can be Z0 if nothing is done on the stack, that is no push or pop operation is performed on the stack. Or third case is what? This symbol A may be pushed onto the stack, and not necessary at a time you should push one symbol onto the stack. Multiple symbols may be pushed onto the stack. Okay, or multiple symbols may be popped from the stack. So there are four possibilities given for the transition, that is given like current state, current input symbol, and the stack top symbol. There are four possibilities, and it will determine what, where P is the next state, and gamma here is the what, stack content. So what this indicate? This can be empty if the stack operation perform is pop, that is Z0 is popped from the stack. Second thing is what? If this is a Z, if the stack is not updated, Z0 we can say. Okay. So what are the possibilities? Okay. So first possibility is what? This is a epsilon if Z0 is popped from the stack. This is a epsilon. Second case is what? It is a Z0 if stack is not updated. No push or pop is performed. We have seen this, how to write the equation, transition equations. Third is what? If multiple symbols are pushed onto the stack. Here I have written late. This is not necessary, it should be same. This can be different symbols. So multiple symbols are pushed onto the stack. Initially stack पे क्या था, Z0, and this multiple symbols are pushed onto the stack. Fourth case क्या है? Multiple symbols pop from the stack. If Z is pop out and also multiple symbols are popped from the stack, okay, and multiples or no, this is not the case. If Z0 is pop and Z0 is pop and multiple symbols are pushed onto the stack. Those who are not knowing, we have already seen this, but we are just doing revision in brief. So multiple this X symbols are pushed onto the stack. Okay. So these are the four possibilities for the gamma we have seen for the transition. This is a DPDA. In case of NPDA, what we have seen, there are the multiple transitions for the same input symbol. So I can write like what? Let Q0 A Z0. Then there can be the transition, let P1 gamma 1, or it can be P2 gamma 2. So let there are M outgoing edges for the same A symbol, that is read. Okay, so you can take any one of this path that we have seen in case of NPDA. Okay, so after that we have seen the problems which can be solved using NPDA and the DPDA. Okay, so like NFA and DFA have the same power, here it is not the case. NPDA is more powerful than DPDA. Than DPDA. Okay, so example of this is, you can consider what? Palindrome of odd length as well as even length. We have seen that you cannot solve using the DPDA, you have to design the NPDA. Even for the context-free language or the context-free grammar, we have seen that is how to convert context-free grammar to the CNF form, and then Chomsky normal form, and then design the NPDA we have seen. Okay, so NPDA is more powerful than the DPDA. Okay, so now we have to consider what is the problem. Let this we have seen regular language. Regular language we have seen it is accepted by the finite automata, which is a subset of what? Now here I'll separate NPDA and DPDA. Let this is my DPDA, and NPDA is more powerful than the DPDA. Okay. NPDA accepts the what? Context-free language. Context-free language is a what? Language generated by the context-free grammar, or it is also known as a type 2 grammar. This already I told, type 0 grammar. Okay. So now after this, what we have to consider? We have designed the now finite automata for the type 3. This we have designed for the type 2. What remains now? Type 0 and the type 1. In case of type 2, we have seen all the productions are of the form A derives alpha. Type 2 is a what? Context-free grammar. What type of productions are allowed? A derives alpha, where on the left hand side only one non-terminal occurs and the right hand side is a sentential form. Okay, sentential form is a what? It is a string of terminus and the non-terminus. So next what remains, which is the most powerful machine, and that is what we are going to design now. That is the Turing machine. Turing machine, it accepts the language generated by type 0 and the type 1 grammar. Okay, so this will also accept the language generated by NPDA, DPDA, as well as the regular language, as it is the superset of all these types. Okay, so design of this will be complex as compared to the NPDA or the regular language. Okay, so now let us consider what are the elements. So whatever the limitations of regular language or this context-free language, that is limitations of finite automata, DPDA and NPDA. Okay, those limitations we have to overcome in this Turing machine. Okay, so let us consider the elements of a Turing machine. In case of NPDA or DPDA also, we cannot perform any write operation to the tape. Okay, so let us now start with the Turing machine. Okay, in case of NPDA or DPDA, we have solved the problems which we have not solved using the finite automata. That is what well-formed of parenthesis we have solved. Palindromes also we have seen. Multiplication of two numbers that we have not solved yet. This will be we are going to consider for the unary numbers. Okay, so multiplication of two numbers, that is not solved using NPDA or DPDA, but now those type of problems we are going to solve using the Turing machine. It may be multiplication of number, it may be addition, it may be GCD, greatest common divisor, or it may be division. So all such type of problems we are going to solve now in this Turing machine. It also, this Turing machine, we are going to solve the problems of the type what? A to the power n, B to the power n, or C to the power n, or palindromes, well-formedness of parenthesis. It can accept all those languages because it is the powerful and it is the superset of all this. Okay, so यहाँ पे what is our conclusion? Finite state machine, it is the minimal machine, whereas Turing machine is the most powerful machine. Okay, यहाँ तक clear है? Whatever I have explained, please type it in the chat so that I will give the introduction of the Turing machine now. Is this part clear up to this? Yes or no? So that I will continue now with the Turing machine. यहाँ तक clear है या नहीं? We are not shown here separate NFA and DFA. Why? Can anybody tell me now? यहाँ तक तो पूरा revise किया हमने. I want answer in the chat. Otherwise, I'll assume that you are not getting anything. Yes, Atul, number 20. Remaining students, you can put it in the chat. Is this part clear? So I ask Atul, so Atul just put the message. What about other student? यहाँ तक clear है या नहीं? Om, 29 number. Om is there or not? Yeah, this is a very important part of this subject. This is what we can say, this is heart of this subject. If you understand this, number of questions are framed using this. You may have seen the MCQ on this in PDA MCQ test. Okay. So shall we start with now Turing machine, our new chapter or new unit? Okay. So next, our unit is the Turing machine. And please concentrate, and it is my suggestion to you that don't miss any lecture, because generally what is our observation is that students find this Turing machine very difficult. It is not that of difficult if you practice and if you attend all the lectures. Okay, for other lecture I have not told, but it's my appeal to all of you, please don't miss any lecture of the Turing machine, because I will try to solve many problems in the lectures only, so that you'll get the idea about solving this. Okay, because here I told that we have to perform multiplication, division, GCD, etc. Okay, so don't miss the any lecture. So today I will give the introduction of this Turing machines. Okay. So using the Turing machine here, as the why the name of this is Turing machine, because it was proposed by the Alan Turing. Okay, so that's why the name is here. It is a Turing machine. Now, what it consists of? What is the difference between the PDA and PDA or the finite automata? Let me tell you. We know that we are writing the input on the input tab. This is what just to represent one symbol in one cell. Now, up till now, what we have seen in the finite automata as well as in the PDA, this tape, it was bounded at the left end. So what is the difference here it is showing? Your tape is unbounded on both ends, left as well as the right. Okay, remaining here, this is an infinite tape, you can say blank tape. Remaining part here is what you can say, it is a blank tape. You can note down this thing. Each time I will not tell you to note down. You can note down whatever I'm writing here. Okay.
Ma'am, just a minute. Hello.
Yes.
Yeah, Shreya, please rename yourself. Please continue, ma'am.
Shreya, each time we have to inform you. Huh? Please remember that. Okay. So this is your input what? And now remaining tape is blank. No. This is your input string. Okay. So to indicate the end of the left end of the string as well as the right end of the string, you may use the blank. If explicitly not specified in the problem, it can be any symbol here other than the symbols which are in the input string. Okay. So here I am using what? Blank in this case to indicate the left end of the string, blank also to indicate the right end of the string. Remaining symbols can also be blank here. Okay. So this is what now we have seen head. Okay. This is my head pointer. Okay. Here I am writing read as well as right head. So what this indicate? Using this head, you can perform read operation as well as you can perform the write operation. Okay. Up till now in finite automata and PDA, what we have seen, we can just perform the read operation. That is, we can just read the input symbol. We cannot modify the input string symbols, but here it is a read write head, so you can modify the symbols of the input string. Now here also there are finite number of states, so I'm just writing here state. This indicate in the current state, this is a head pointer. And finite control means what? There are finite number of states as well as finite number of symbols. Okay, so this is a state, this is a what I have written, finite control. Okay, so this read write head, it can perform read operation as well as write operation. Now after performing read write operation, it can move to the left, it can move to the right, or n means remains at the same place. Okay, So N stands for no movement. Okay. So what are the possibilities here? Using head pointer, this is a current state. In the current state, this head pointer, it can perform read operation or the write operation to the tape. And after doing that, it can move to the left by one cell. One cell means what? One input symbol. Or it can move to the right, or it can remain at the same place. So N stands for the no movement. Okay. So let I here indicates the finite set of symbols. In mathematical model, the notation will be different. We'll be using Q, and for the input alphabet, we'll be using the summation. Okay. So let us consider machine function, state function. Here S is again what? Finite set of states, and S is a finite set of states. Okay. And one more will add here, that is the direction. So what is the direction? I told direction can be L. L stands for left, R stands for the right direction, and N stands for the no movement. Okay. So direction here D, it can be any one of the, it can be L, R, or the N. Okay. So now here there are three functions: machine function, state function, and third function now added is the direction. Third function added was the direction function. Okay. So machine function here, it is the same that we have seen in the finite state machine. Machine function here is a what? Input, and the state, it determines the I. Here output set is not different, because whenever anything is to be changed, here it is changing the input only. Okay, input symbol we are going to change using the write operation. Okay, so that's why here it is what? In machine function is what? Given the input symbol and the current state, it determines this I. I is a what? I is again a input symbols. We have seen finite set of symbols. So O is not different here. Okay, so that's why it is I input symbol, and the state determines the next, what is to be written on the tape. State function is same. State function is what? Given the input symbol and the current state, it determines the next state. This is the second function. Okay, machine function, state function, and now the third function here is a what? Is the direction function. Third function is a what? Director function. Okay. So direction function here is what? Again, here it will be what? Input. Like here, this is your input symbol and current state, and then it determines the direction. So what it needs? Given the current input symbol and the current state, it determines the direction. Where D, I told it can be L, R, or N. Are the three functions clear? New function added is only what? Direction function. Because here you can move, head pointer can move to the left, right, or remain at the same place. You can perform read as well as the write operation. Is it clear? Okay. So now here, okay. So this action, so what are the actions here that it is performing? There are three actions. What are the three actions? Three actions at a time. These three actions are performed. Given the input and the current state, what it will do? Either that input symbol is erased or replaced by some other symbol. That is this case. What is the problem? Anugrah, is there any problem? Should I explain this again, or I didn't get what you have written, read, write, or no movement? Okay. So there are three actions, correct? So here in this first action, given the current state and the current, sorry, this is your state, current input symbol and the current state, Either it will erase that input symbol or replace it by some other symbol, or it will just perform the read operation. Second action here is what? State is change, state transition, no? So current input and the current state, it will determine the next state. Third action is what? Direction. Either it will move to the left, right, or no movement. Okay. So there are three actions performed at a time given the input symbol and the current state. Okay. For example, if this is given, suppose, okay. So if this is given, if this is my current state, sorry, current input symbol, if A is my current input symbol and alpha is the current state. This is the current input symbol, A is the current input symbol and alpha is the current state. So what I told, there are three actions. So I'll write here, if I'm writing this, can anybody tell me the meaning of this? So each of this is output of one of this. Can anybody tell me? Just guess it. I told there are three actions takes place given the current input symbol and the current state. So what this B indicate? Can anybody tell me? This B is the output of the machine function. Beta is the output of the state transition function. This L is a direction function. So what is this B? Can anybody guess? What is B? What will be the B? Yes, can anyone guess? You can type it in the chat or unmute yourself and tell. No, it is not next input symbol. What is it? This A, it is replaced by this B. It has performed the right operation, meaning is what? This A on the input is erased and it is replaced by this B. This alpha was the current state and now the state is changed to the beta. And left is what? It moves to the left direction. Okay, I'll explain this on the tape so that you will understand. Before this transition, let my input is, suppose all the A's are there and suppose you want to replace this by B. Suppose this is your case. This is how you'll represent the tape, unbounded on the both sides. Okay, this blank indicates the left end, this is the right end, and our string is triple A, and this is our head. What is the current state now? Current state is alpha. This is how we can show. So what indicate this? Current state is alpha, current input is A. So what is the action here? I told three actions takes place. This A is replaced by the B. So what is written on the tape now? B, which was not possible in the finite automata and PDA. Get the difference. You can perform right operation here. So this A is replaced by B. After that, what happens? Okay, I'll not write here. Let us keep this as it is. A, and I will show this tape again here. So after this transition, this A is replaced by the B. Okay, then state is changed to what? Beta, and it moves to the left. So here your head pointer moves to the left and the state is changed to the beta. Is it clear now? This is a blank, this is not B. Unbounded on both ends. Is the transition clear? Is it clear? A is replaced by B, state is changed to the beta, and it moves to the left. Okay, now instead of, let us consider this is only our initial case, and now if my transition is this way, now tell me what is the difference here? What is the difference here? I'll show the tape after this transition. Before this, this is your case. Alpha points to the A, and after the transition, who will tell me? What is the meaning of this? Okay, so A is replaced with C, correct. Then it moves to the right side and the state is changed to the beta. Okay, so this A is replaced by C. Then our head moves to the right from this to this next cell and the state is changed to the beta. Your state can be Q0, Q1, anything. Here I have just considered, for example, alpha, beta are the states. Okay. Third case क्या हो सकता है? If I give here A alpha is equal to D beta and no direction. यहाँ पे क्या होगा? Can anybody tell me? What will be this case? इस केस में क्या होगा? A is replaced by D, correct? Then, yeah, after that what? 3 actions होते हैं ना? A is replaced by D. Alpha state is changed to the beta. And direction is what? No movement, correct? Okay. So these 3 actions takes place. So it may replace or may not replace. My case may be like this way. A alpha, it just moves to the left. Suppose this is my case. So what this indicate? What this transition indicate? A remains as it is. State alpha remains as it is. But what is the direction? Only the direction is changed, no? In this case, it moves to the right by 1 cell. Okay. So it may be the case. The other case may be what? It changes the state as well as the direction. But suppose A alpha is equal to A beta comma right. This may be the case. Symbol is not changed, but state is changed from alpha to beta and it moves by 1 cell to the right direction. Okay. So now how to represent this, that I'll explain using the, we are going to write the MAF or functional matrix in which represent everything. We are not going to use the 3 separate tables. Okay. We'll represent all these actions in a single table and that we'll see as a functional matrix. Okay. Instead of representing 3 different matrices, one single matrix will be using and it is what, okay, what is it? Okay, so functional matrix, how to represent these actions and the functional matrix. Okay, so this is not some example, I just considering to explain the how to represent this functional matrix. Okay. So what this indicate? S is the states. So states here will be representing using the rows alpha, beta, and let gamma. This indicate what? The symbols. And symbols which are written on the tape. So it may be erase symbol. And if you are using input to end with the blank, that character also you have to consider. So these are the tape symbols, no? Okay. And here we are going to write the action. Okay. So how to write the action? See. So if I am writing here A alpha, okay. So where A is about input symbol, alpha is a state. This 3 as a triplet will write in each entry. This is after transition, no? Next, this is input symbol, state, and the direction. So we'll use each of this using the 3 triplets. So if I'm writing 0 alpha, I'm not giving the comma. So what this indicate? If the current input symbol is 0 and current state is alpha, after the transition, this is what my next. Okay. So 0 remains 0, state remains alpha, and it moves to the right direction. If you are not getting, please ask. What is the meaning of this? Can anybody tell me the meaning of this? So this is like what? 1 alpha, it determines what? 0 beta r. 1 is replaced by 0, state is changed to the beta and it moves to the right direction. So this is what it indicates. Then if I'm writing this blank alpha r, if there are no actions here, you can keep those as a blank entries and you can show it by the dash blank gamma n if this is. So this is how I'll represent it in the functional matrix. So what it indicates, suppose how to represent it using the minimal notation. So 0 input is not changed. Alpha state is also not changed. So no need to show this 0 alpha here because it is not changed. You can just write here R. Okay, because we are just moving to the right. So let us consider simplified functional matrix. If anything is not changed, if the state is not changed or input is not changed or the direction के लिए you have to show it or you have to show it either L, R or N. But for the input or the state, if it is not changed, don't show here like here. So simplified functional matrix. Okay. So this is my simplified functional matrix. Okay. So here, what is not changed? Input is not changed. State is not changed. Only you are moving to the right. So just show here R. R indicate what? Move to the right. Now here, what happens? This is changed. No, 1 is changed to the 0. State is also changed to the beta. And you are moving to the right. So this cannot be simplified. You have to write this as it is using 3 tuples, 3 symbols. Okay. In this case, what happens? What I have to write? Now you know how it will be simplified. Alpha and blank. Yeah, you will just write what? R. And this is as it is. So it is blank. Here, I will write this entry. Yes, it is a gamma. It is a gamma. It is not a, this is a state gamma. Okay, we have written R later. It is not R, it is a gamma. Blank is not changed, but state is changed and direction. So you'll write only this two. The remaining is blank. So you can write like this way, simplified functional matrix while designing your Turing machine. Okay. Yeah, the clear है functional matrix, how to write it, how to write simplified matrix. Okay. So now mathematical model, let us consider. Okay, so let my Turing machine is denoted using M. Here, again the same will use. For the final state, generally here we'll use it as a what state of final states or the hard states. Okay, you know the now meaning of all of this, only something is different. Here there is no stack. But it is powerful because you can perform the right operation. You can modify the input symbols here. Okay. So now tell me the symbols, one meaning of each of this. All of you know this now. What is Q? What is Q? Yes, Q is a finite set of states. What is this? Yes, it is a set of input symbols. It is a finite set of input symbols or input alphabet. That is also correct. Finite set of input symbols. Okay. This is different now. In case of PDA, we have seen it is a stack alphabet. What will be the here? This, can anybody guess? ये तो input allowed है. Okay, whatever the symbols given in the input string, what will be this? Can anyone guess? I told that you can write on the tape. Suppose agar my input string is formed using 0 and 1, I can replace 0 by any symbol. On the tape, I can replace 0 by A. Even 1 can be replaced by B. Yeah, that is correct, Ketan. Very good. It is a what? Tape alphabet. That is the right answer. Yes. It is a finite set of allowable tape symbols. It is a finite set of allowable tape symbols, including blank character. Okay, so write this detail, including blank character. Including blank character. Okay, कितने हो गए अपने? Q this. Okay, I'll first complete this and then we'll consider the transition. So Q0 will be what? You know, all of you know what is Q0. Q0 always we are used for what? And in this case, yeah, it is the initial or start state. Okay, and this will be from your Q. Yeah, this will be an element of the Q. Okay, here in this input alphabet, what is it? It will be the subset of, yes, this tape alphabet. Is it correct? This your input alphabet, it will be the subset of, yes. Is this statement correct? In finite set of input symbol, it is a subset of the tape alphabet. ये correct है या नहीं? This statement, note down this also. This is a subset of tape alphabet. Okay, Q0 हो गया. Now F is a what? What is F? F is what? Yes. You can write set of final states. Set of final states. Or now here we'll be using let halt states.